Hi, everybody. Welcome to ACT Cram Night 2. Today, we're taking a break from the humanities, and we're going into the STEM fields. And by STEM, I mean the M. Steven, since you're here with us tonight, would you like to give any opening remarks, our guest of honor?
What does the rest of STEM stand for? It's sciences, technology,
Engineering.
Engineering. So engineering gets its own letter, but technology is just wrapped up. I feel like the person who invented that was an engineer. Anyway, welcome to the math section of ACT Crams. So stoked to have y'all here. We have Elias and Dylan who are going to be walking y'all through the finer points of ACT math, which is going to be fantastic. So I hope you got those TI 84s dusted off and ready to go, or whatever calculator of choice that you have decided to use. And we will go ahead and get on right into it. As a reminder, this is going to be 2 hours long. We are going to have a quick survey at the end for y'all to fill out. So just be on the lookout for that. And please take a few minutes to do that. That helps us out a ton. All right, Elias and Dylan, take it away.
All right. So, welcome everybody. Welcome to night 2. We're getting ready for the ACT coming up on Saturday. And I want to take a moment, if we can move on to the next slide, and take a moment to introduce myself and Dylan. Hi, I'm Elias. As was said before, I am a freshman at Bowdoin College, and I see the ACT as this big old game, which is why I am having so much fun teaching y'all how to break that game. We're going to help you tonight. We're going to go over content. We're going to go over calculator stuff. We're going to go over Dylan. Dylan, introduce yourself.
Hi, everyone. I'm Dylan. I'm now a junior as of today. I'm a junior at Northeastern University studying economics and history. Elias is totally right. This test is a game. It's all about getting points. And we're here to teach you how to play that game and succeed on that exam. I'm super excited. I'll be talking mostly about kind of a lot of the probability and statistics stuff tonight, which is kind of my forte. So I'm excited, y'all. I'm excited.
Dylan beat me to the punch, not actually, on the stats and probability. That was always my favorite too, but I'm here to help you out with everything else, especially things that require this, because this is your best friend on that exam. Very funny that you're being taught math by 2 history majors.
It's because
but you know what? How we roll. Anyways, let's move on to the next slide. Okay, gonna go through this quick. Follow us on TikTok. Follow us on Instagram. Follow us on the YouTubes. Follow us on the LinkedIns. My favorite. That's my favorite. Follow us on everything for all the memes, for all the updates, most importantly, and all the meme updates. That's what I have to say on that front. You should follow us on all of it. Anyways. So, you guys, y'all are already friends with us on Cram mode, but don't forget, take advantage of the practice questions, take advantage of the study guides, take advantage of the cheat sheets, take advantage of the study plans. We're here to help you. You're friends with us now, so use it to your full advantage, all right? You're our besties, you get all the benefits. So, that's what I have to say on that front. Community agreements. Y'all are aware of these. Y'all have been with us for a while. Just gonna speed run through these. Respect. Be respectful. Support. Support each other in the chat. Patience. We have a lot to get through, but we promise we're gonna get through all of it. And be kind. We're all real people. At least I really hope so. I feel like if AI is gonna be able to disguise themselves anywhere, it's gonna be in the math section. But, it is what it is. Okay, I'm seeing a very big combination of, mids feeling comfortable, and I see a -10. But don't worry, we're going to get that -10 up higher. We're going to get all those numbers up at least a bit higher. But to do that, we got to get into this. So, we got through our welcome. We're going to cover the basics of the ACT math section, what to expect. We're going to get through the preparing for higher mathematics, which is basically if it's a pyramid, your lowest foundational level. You're integrating essential skills. That's the application of those basics. And then wrap up And by then, I'm not going to see any more 3s, any more -10s, any 2s, 1s. It's all going to be solid 7s or highers. And 7 is better than you think it is, honestly, especially with the ACT math. So, as our owl friend says, woo, is ready to learn tonight. So, get into the basics. See, you guys, we got writing, we got those things, I forget, they start with an A, I don't know. And we got smiley faces, so happiness with math and writing with math, which means you get to use those humanity skills within this. So let's go ahead and get right into the basics of this. We're gonna get through that pretty quickly so we have plenty of time to go over content with you guys. So this, in my opinion, is probably the easiest section in terms of amount of time in proportion to the number of questions. And we give you, hopefully you guys know this word, a linear expectation of time per question. But it's important to note that in the ACT math section, the questions start on a lower difficulty scale and get harder. So do not expect to be taking 60 seconds per question on all of them, but that should be your average, your mean, if you will, or lower. I mean, your mean could be lower, whatever. But as a major tip, bring a watch, bring a timer, bring a stopwatch, or as I'm going to continue saying every single one of these nights, if one of y'all brings an entire analog clock to your ACT, message Think Fiveable on Instagram and say you have a very important research development for Elias, because I want to know they would let you use your giant analog clock. One of the little ticky ones. But do not bring a smart device. I will say that. Do not, because then you're just not going to be able to use it, and then it's not helping anybody in this case. So just bring a normal standard watch, some sort of stopwatch. Be aware of the time that you're using so you can pace yourself, accordingly. So, with that being said, that's like the very broad basics. So, moving past that, details. So ACT math is split into what I like to say is 2.5 different sections. And by 2.5, I mean one of those sections is like a bunch of them. There's another section that's just a section. And then there's modeling, which is the half. So because it just kind of connects to the other two. So preparing for higher math is like your foundational skills, understanding concepts. While integrating essential skills is your application, a little bit more word problem-y. And fun fact pertaining to both of those, unlike the SAT, you can use this as much as you want. You could be on question 1 and go 1 plus 1. There you go. You got the answer to 1 plus 1. Whatever you need it for. Modeling can be connected to any of these. That's kind of why we went over different kinds of graphs on the preview, because you can see different kinds of models. This isn't the most common thing, but it is a thing that comes up. Now, warning, as I said earlier, don't expect to use exactly 60 seconds for each question. Go fast at the beginning. Those first ones are going to be so easy, and it's going to get harder as you go. Use that beginning to instill some confidence in yourself, but know the last 10 are going to be the most challenging questions. Do not be afraid to use every resource that you can legally bring into that exam. I'm not a math guy. I still got a 35 by using a calculator for every single question that I even had any hesitance on. Once you build up those calculator skills, it becomes a lot more easy, and it helps you break down those questions a lot better. And I'm going to be helping you figure out how to use those as we go through some of the practice today. So, that's some of the basics, some of what to expect. If you want, you can take a moment to look over the preparing for higher math, except not that much longer, because I want to go to the next slide. I want to start teaching you guys some stuff. Preparing for higher math. So where are we going to start on that front? We're going to start off with, there we go, going over what's in them. Numbers and quantities, algebra and functions. I would say this is the most foundational things you need to understand. If you're coming in here and you don't know what a number is, I'm sorry, I don't know how much I'm going to be able to help you today. But a lot of these kind of have some overlap. A lot of things you might see in numbers and quantities also goes into algebra, also goes into functions, Some of the biggest difficulties I see people have troubles with is matrices. Matrices. Enough that it's brought up in 2 sections. Notation can be difficult, but it's not a very common thing on the exam, so don't stress too much. Manipulating functions, we'll go over that, don't stress. And then real and complex numbers can cause some difficulty. But I would say a lot of this, if you understand parts of it, you'll at least be able to extrapolate everything you need to know. We're still going to cover all those basics, though, so we can help you see some of those extrapolations and some of those connections. Now, there's another 2 major sections, if we can move on from this. And you'll see they're a little more advanced, and we denoted that by making them a brighter color and using more words. Geometry, it's not particularly hard. It looks a lot scarier when you put into words, but a lot of it is just understanding how shapes work in relation to each other and being able to like figure out the area, or dare I say it, the volume. Don't worry, we'll have you guys. Trigonomic ratios, that's one of the things I struggled with the most. We're going to recover that. SOHCAHTOA, all that jazz. And then statistics and probability is the one I would say people are usually the least familiar with. If you are somebody who has taken AP Stats already, I know I did say volume. If you're not somebody who's taken AP Stats, this might seem daunting because it's usually not a hugely highlighted part of the exam. It's usually just kind of, or of class, sorry. It's usually just a smaller part. But good news, the same is true on the ACT. Usually if you're going to see a couple of statistics and probability questions, they're going to be later on the exam. It's not going to be one of the first things you see, unless it's like, here's a bag of marbles. What's the chance it'll be this color? Here's the number of each of them, which at that point almost just goes back to numbers and quantity in a word problem form. But don't worry, we're going to be covering all those hard subjects tonight. So let's get into this a little bit. Number and quantity. We're not going to go over every single little thing. We're not going to explain what a prime number is to you guys. We're going to go over the hard stuff in this section, so we can have more time to go over some of the more difficult things in other sections. That being said, I believe we're starting off exponents, I think. Yeah. So you're going to see exponent things. I'll be completely upfront with you. And they look terrifying. If you can remember these 4 things, you've solved every properties of rational exponents question they're ever going to throw at you. Dare I say it, you're not even going to see the a to the power of negative x situation very often. I would recommend memorizing it for the sake of understanding. But the first 3 are going to be the ones you really want to focus on. When you're multiplying 2 numbers that have the same root number but different exponents, add those exponents. Dividing, subtract the exponents. It's almost like you see that there are exponents, you see the same root number, and you just pick the simpler version of that initial concept. So multiplication is just adding a bunch of times, division's like subtracting a bunch of times, and you just do that to the exponents. The hard one I think people have trouble memorizing is the last 2. I would just say, you know that root number x times root number y is root number x plus y. If you see something to the power of a power, assume that one's not going to be plus, that one's just multiplying. It's a lot easier to remember the basic ones and then being able to scratch out what the basic ones were if you see a new situation than it is to always exactly remember every single detail. And again, a to the power of negative x, you're not going to see very often. On the off chance you do see it, play around with your calculator a little bit. Put whatever the number is into your calculator, and then try out a few of these situations. A to the power of negative x, you only have so many options. That's just a case of trying to figure out, okay, what does 4 to the power of negative 3 equal? Well, that equals a very weird decimal, but it would eventually be what is 1 to the power, or 1 divided by 4 to the power of 3. So being able to break it down into those foundational ideas can be really, really beneficial. On to the next concept, and if you need us to recover any of this, go right ahead. Scientific notation. This is another one that isn't going to come up all the time, but is very important to understand. And basically what scientific notation does is it takes it takes a number that is very large or very, very small, and it makes it a little easier to read. And in this case, you can actually set your calculator to be in scientific notation so that if you ever have something that's very, very large, it'll automatically put it into scientific notation for you. So I can just put in a bunch of random numbers and it'll put it into scientific notation. And I recommend doing this because if you're ever going to see a scientific notation question, it is simply just going to be, what's this big number in scientific notation? And I see somebody in the chat, my wonderful co-host Anuva, asking, are you allowed to do that? Yes, you are allowed to do anything with your calculator that you want in the whole entire world, as long as you're not downloading any new programs onto it. You can change any of the modes. You can use Solver. You can use the really advanced calculator things. And you can get to that section by hitting Mode, which is going to be right next to your second button. And it's going to be on the second row. The default will be normal. You're just going to want to put it over to scientific and hit Enter. Boom, it'll be scientific mode. You can switch it back to normal. Once you can get in the process of doing that very quickly, easy process. You can switch things from scientific notation into normal, vice versa. Makes your life a lot easier. If you struggle with scientific notation, know that that is there as a resource. Even if you don't struggle with scientific notation, it can help you out. Okay? So, next section. Matrices, matrices. The trick being that no one particularly loves these. It is an array of a rectangular array of numbers or variables, and it looks like something that you should see in geometry, but it's not. It breaks your heart. But good news, if you're ever going to see a matrix, can you move to the next slide so I can show it? It's never going to be any of the super complex matrices. This is basically what you're going, everything you're going to see on the exam. The hardest one being the multiplication. If you add a multiplier to your initial variable that shows this matrix, just multiply every number within it by the coefficient. And Dylan makes a great point. A matrix that has dimensions A by B means that A is the rows and B is the columns. Not A across. A is going to be this. Wait. There we go. Not A across and B down. Easy mistake to happen. Not usually something you're going to have to be too concerned about, though. And in that situation, I would just look over your answer choices as well. The other thing you might see revolving or around matrices is adding or subtracting them. And in that situation, don't let the number of numbers confuse you. Take each location. So A and W are in the same spot on our diagram on the left or right. Your diagram on the right, you're going to add A and W. B and X, same position, you're going to add those two numbers. Basically, if you were to take the two matrices and put them on top of each other, you would add or subtract the numbers that would end up being on top of each other. Don't rotate it. Don't try and multiply numbers in any strange way. Add. Just add positions based on where they are. You're not going to ever see anything with different dimensions from one another. You're not going to get anything that's weird and puts weird coefficients in strange places. You're going to be fine. Really, the only time that would come up is with the multiplication and division of matrices. You can't even add and subtract matrices that are different dimensions, so it's not going to come up on the ACT. We're here to help instill some confidence here too, people. Don't let yourself stress out over things that are not going to be on the ACT. These big, scary concepts, usually they aren't even going to get into any of the big, scary things. So if you ever see them try and do something like that, there's probably another element of it that you might maybe be missing within the writing of the question, or even if you're completely lost, just look for the answer choice that you can reverse solve the most easily. So that's basically it for matrices, and a lot of people fear them a lot, but if you can remember those two basic things, is that like add and subtract in the same position, if there's a coefficient, multiply by each of those numbers, you're going to be completely good. You're going to be all good for this. Okay, and I think we can move to the next slide, perhaps. Yes, that is like Okay. Actually, can we go back a slide? Because I'm seeing a really good question in the chat. How do we know when to add, subtract, multiply, and divide? I think what you're seeing right now is a great example. For the case of the ACT, you're going to know to multiply, and you're not even going to have to divide. You're going to know to multiply because it's going to show you the original matrix, whatever. And they're going to say, if A in this example is multiplied by 2, or if A becomes 2A, what would the values within the matrix look like? Something along those lines. Or if A equals this, what does 2A equal? And that's going to be an indication that, okay, I'm multiplying each of the numbers inside by that coefficient. For the case of addition and subtraction, it's literally only going to look like what you see on the right. They're going to be like, add these two. Find the sum, find the difference. Sometimes they'll use those bigger math words. But what you're seeing here is basically what you're going to see on the exam. Lana, it will definitely be at the finale if it is not already covered in the practice tonight. I do not remember quite off the top of my head, but during Q&A, if we need to come back to this, I'm happy to even like scribble up a question for you guys. I think there's a question within the practice. I'm not positive, and if there's not, I will add 2 questions about it to the finale, just for you. So, yes, please don't be afraid to ask in the Q&A. And AP Class Study makes a great point, but it's not something you're going to see on the ACT. What I'm trying to make sure you guys know, what we're showing you is all you're going to see. We're not hiding anything from you guys. Do not stress too much, okay? So, that's all we need to cover for numbers and quantities. Anything else that would be considered numbers and quantities will also be covered by algebra or by functions or by geometry. So, let's move into the algebra section real quick. Maybe. There we go. Rocket ship. We're going right into this. All right? So, first topic, quadratics. And we're starting off with this one because it's scary. And it can be scary. So, a quadratic is any polynomial of the degree 2 or higher, depending on what you're taught. But in this case, it's 2 to the degree of 2. Its standard form is going to be f of x or y equals ax to the power of 2 plus bx plus c, where a, b, and c are constants. They do not change. They're not variables. However, not all quadratics are always in this form. As long as the highest degree ends up being 2, which means including after multiplication, it is a quadratic. And there's a lot of factors to solve them. My favorite in the whole wide world is called numeric solver on your calculator. And it is a little difficult, but we will get into that. It's not that hard. The biggest thing is you have to test 2 values instead of just 1. So take a second in the chat and tell me which of the following are quadratic equations, or if any, or if all of them, or if none of them, or if only some of them. I'll wait for a couple answers to come in. I need at least a couple before I can move on, just so you know. Okay, I'm seeing an A. Can I get another answer or 2, maybe? Got to make sure y'all are awake for this. Okay. So what if I told you a little secret, friends? I'm seeing a lot of all except C. I'm going to tell you guys a little secret. C, depending on what you're taught, can also be considered a quadratic.
Elias,
what?
I don't think C is a quadratic. You can be factored to have one of its terms be a quadratic, but it's not a quadratic.
Oh. Okay. I apologize. My definition was always taught that anything above x to the power of 2, so x to the power of 3, 4, can also be
a quadratic. It's exactly 2.
What? Okay. Well, Dylan is speaking from above. Y'all are smarter than me. Good work. A, B, D, E. Look at Dylan using his junior brain. This is what I get for being a freshman. So, yes, all of y'all are right. Speaking from the darkness, A, B, D, E. Correct. I apologize. That is a definitional error on my end. So, Yes, you guys got it right. That is an amazing moment of brilliance for you guys. Y'all are even smarter than the teacher here. So, moving on from this, going into this a little more, I suppose. Whoa, okay. Factoring. I don't know why that says SAT. I suppose it's true of the SAT as well, but in this case, we're speaking of the ACT. So they'll expect you to know how to factor, especially quadratics. So I'll give you guys a little secret. It's not like they're going to check your work, so if you struggle to factor, it's not the end of the world. However, we're still going to go over it. Factoring is basically undoing the distributive property. It's taking, quadratics are on both. So it's taking the longer form and it's breaking it up into binomials, which is going to be your, I'm going to try and verbally say this, but for your reference, if you see the 3-line long paragraph, it's the x plus d times x plus f equals x to the squared plus d plus f x plus df. I recommend looking at your screen to understand that a little bit better. To find that, you need to find the two numbers that multiply to c and add to b, which sounds a little bit weird. In this case, we're going to look at the practice problem real quick. X squared minus x. So a little reminder, in the case of a minus x, you can also see that as minus 1x, same number, makes it a little easier to understand the b value. Minus 20 equals x plus a times x plus b. You want to find a and b. So we need something that multiplies to negative 20 and adds to a plus b. Or adds to negative 1. I apologize. So with a little bit of time, a little bit of practice, you can find that it can either be a equals negative 5 and, or no, it cannot. It can be a equals negative 5 and b equals 4, or you can use b equals 4 and a equals 4 and b equals negative 5. I apologize. So in that instance, your roots are going to end up being, I believe actually, nope, that's correct. I had to check. X minus 5 times x plus 4. Because in this case, the negative 5 times the 4 equals negative 20, and negative 5 plus 4 is going to equal negative 1. So, any questions regarding factoring? This one can be a little bit harder. Again, if you're stressed and you do not understand factoring quadratics, that's okay. There's other ways to solve. The SAT and the ACT will expect you to know it theoretically, but if you have a way of solving, most of the time you're going to be all right. If you can find the answers, you can work backwards from there. I am not seeing any questions. If there is, don't be afraid to throw it into Q&A. But let's move on to the next concept. So, if A isn't 1, it gets a little weirder. And in that case, you're going to need to factor by grouping. It means you're going to have to find two numbers that multiply to AC instead of just C and add to B, and then splitting the B to form groups, which can sound a little bit weird, but we're going to work through this right now. So in the case of 3x squared plus 10x plus 8, which of the following is going to be the correct answer? Now, as a little bit of an example here, you guys, I'm going to tell you how to immediately eliminate two of these answers. X times x is not going to be your 3x squared. It's just going to be x squared. And 3x times 3x is not going to be 3x squared. It's going to be 9x squared. So if you know nothing else, if you know nothing else in this world, me too, relatable, but also you have a 50-50 shot here. Now, from here, the best way to write it out is the way that we did with the answer option towards the bottom, but to give you a little bit more of a verbal explanation, here, one moment, I apologize. You're kind of wanting to split this somewhat into separate groups. And the way that I tend to think of it is you're going to want to figure out how to find two numbers that will multiply to your A and your C, which can become a little bit more difficult. And the way it's written out is really nice. So you'll notice, if you take a second, you can simplify the first half of this longer equation, the 3x squared plus 4x, and split that into two parts, with your 3x squared plus 4x, and then your 6x plus 8. And you can break that down. You can factor out the x with the 3x squared and the 4x, and factor out the x, make that x times 3x plus 4. And then in the other case, you can eliminate a 2 from this. And yes, Arya, you can definitely back solve if that's a little bit easier for you as well. And in that case, you can factor out the 2, leaving you with a 3x plus 4. And that will bring you over into, sorry, I apologize, my throat's a little sore. You will notice that 3x plus 4 then comes out twice. And that's what we're going to want to look for. Because in this case, you're going to need to accommodate both for the x and for the 2. In which case, you find that the factors here are x plus, and then a plus 2. Time is precious. Back solving can take some time. If you like the box method, whatever you find easier, that works as well. Whatever method you find best, you can use whatever method is quickest to you. This is how it is quickest to us. That's how we're going to give you a little verbal explanation. It can also help you understand the basics of it a little more if we write it out. But in case of solving, whatever works for you and is giving you the correct answer works completely fine. So, moving on from this part, quadratic equations and completing the square. And for this one, if Dylan is willing, this is one of the concepts I struggled with a little bit more. And I'm curious, Dylan, is this something that you struggled with? Dylan's at completing the square.
I struggled with it hardcore. I used to hate completing the square. This is like, this is me like evangelizing completing the square. I used to hate completing the square, hated it beyond belief, until I realized the like intuition behind it. And that's when I became such a fan of it, because it's actually super natural, and like a really intuitive and really like sleek method that I've now come to really love. But yeah, like when you teach this to students and it just looks like you're like adding this random b over 2a squared term to both sides, you're like, what is this? Like sure, this works, but there's no reasoning behind like, why are we doing this? Or which means to students, they have to memorize it like I had to do. And then they actually learn to hate it. But in reality, completing the square is actually a super intuitive method. And I think like the most natural method to solving a quadratic. Because it's, when you look at it geometrically, you are quite literally completing a square. That is what it is. So people are always like, well, why does this like work? And there's very clear reasons why this works. Geometrically, you could figure that out algebraically with like calculus. That's fun too. But yeah, it's super intuitive. But yes, it's hard because a lot of the times you just are given this random b over 2a squared constant that you're like, like you kind of holding it. You're like, I know what to do with this, but there's no there's the best, most intuitive and sleek math in my mind is the one where the next step is always, you never have to memorize the next step because it just feels like, of course you would do this next. Like it's what feels like I'm getting closer to my goal.
Mm-hmm.
Sorry, I didn't go on like a philosophical rant about math there.
No, that's a really good explanation. And with that, I would like to say, if you're going to be asked to complete the square, which probably not on the ACT, but if that's the method that you're pushing you to do, it's going to be something similar to this example on the bottom, where the perfect square trinomial is going to be a little bit more easily found. In this case, it's almost an immediate response. Like Dylan was saying, it's almost like a very natural response, because whenever you're looking at the negative 6x, you're going to immediately think, okay, so what would sum to my c here? And it's going to be your, I apologize, it's going to be that 3 times 3, or negative 3 times negative 3 in this case, which would give you that 9. And that's going to be something that comes up a lot more quickly than like something like, even a negative 7 in this case might be a little bit more difficult. Something that wouldn't be as easily broken down. In the ACT, if they're encouraging you to use completing the square, it's going to be in a case like this example here, where, you know, you can break it down, you can split it right into its half, and you can easily find that square. So, however, if that's not the method that you're most equipped for, that's okay. for example, I would still go to the calculator with this one. I was never a fan of completing the square. I am not a fan of completing the square. And hey, Dylan brings up a really good point. Is there another way that you guys can find a solution to this that's coming up? And I'm loving the hint yes here because, one, there's a lot of ways you can solve any sort of quadratic, but also, two, I have a feeling he maybe has one in mind. Maybe.
I do. There's a very specific one I have in mind.
Oh, there's a specific one.
Possibly this totally isn't a hint, but possibly one we've talked about so far. Not
okay.
Not a hint or anything, but
No. So I mean, if anyone wants to throw in a little chat,
a certain word starting with an F,
you know,
and ending in actoring. Not a hint though.
No. Oh, look, someone said it in the chat. Yeah.
Whoa.
Whoa. I know, guys. Amazing. Yeah, this can pretty easily be factored out. In this case, you can take a -2 and a -4, x minus 2 times x minus 4. Boom, bada bing, bada boom, you got it factored out. Got the 2, you got the 4. All clear. Whatever is easiest for you works completely fine. You're not going to be asked to like how they would on the AP exams where it's like, solve it this way. Solve it the way we want you to solve. No, it's all multiple choice. Whatever works best for you. We're going through these different methods in case it's something that you've been like, struggling to understand and feel like you've almost got. But if there's a specific way that works best for you, completely good. Completely cool. So we've been on completing the square for a while. Let's move on to the next concept. More completing the square. We talked about this so much. I'm going to suggest, yeah, we went through this. We're good. And the guy, the lad, everyone's best friend, the quadratic formula. And I'm going to be completely honest with you here, guys. If you're thinking about using the quadratic formula, it's not necessarily needed. I am suggesting, if you know the quadratic formula best, go right ahead. But if you hit second, if you hit math and you go up to the numeric solver, you can go into here and it'll say E1 equals E2 or E2. Set E1 to 0 if it's just Y equals, and then put in whatever polynomial. Dylan, can you throw in a quick, or quadratic? It works for polynomials too. Throw in a quick basic quadratic into the chat for me, somebody, anybody? X squared plus, oh, okay, that's, okay, I'm cool with this. 3x squared plus 4x plus 8 equals 0, equals y, equals f of x, whatever. And it's going to come up with this little equation, and it's going to look like it's off. Pretend that 0 is a y. Okay, we're having another question. So math is going to be right under the green button, and I just tab up. Sorry, I'm trying to get to focus. To numeric solver, it might just be solver on your calculator. Hit enter. Make one side your 0, which is going to be your y, it's going to be your f of x, and then your polynomial or your quadratic on the other side. And this is even a little bit more of a complex one. And from there, you're going to see x equals 0. But that's not right, friends. X does not equal 0. What you're going to do in this situation is I like to put a small number. So in this case, I'm going to put -10. We'll put -10 for the sake of this. So -10. I don't know why I keep looking that way. And you're going to hit, oops, not -10. I lied. See, that was a trick, you guys. Okay. Dylan, I'm not, part of me is wondering if this is, yeah, I don't think this is solvable.
Oh, does it not have, sorry, I typed random numbers.
Oh, you're fine. I'm going to do x squared plus, this might be, that might be a case of imaginary too. That might be part of the issue. Plus 5 or plus 3. So x squared plus 10x plus 3. And if you have a guesstimate for your higher number, amazing. You can do, why did I put multiply? There we go. So x squared plus 10 or minus 10x plus 3. Okay, it has no real solutions? Thought maybe. So if you have any guesstimates, that works too. But you throw an upper guess, it doesn't even have to be accurate. You can put x equals 9, and I know it's not x equals 9 in this situation. Sorry, I'm trying to think of an equation that would give you guys flat, easy numbers. But in this case, your higher number here is going to be this really long one. And you're not going to see one that complex on the exam. I just literally threw in random numbers together that was pretty sure would work. And then you throw in a smaller number, and it'll give you your second value. And in this case, it's not going to give you guys an easy answer, guys. I'm just using this to show you guys how solver works. But basically what you're going to want to do is you're going to want to put a higher guess, something that you would assume is around your higher root number, and then you're going to want to hit graph. And it's going to spit out a random number, and that's going to be one of your x values. But since quadratics are going to have two solutions, you're going to want to put in what you think your lower value will be. So I just put in 0. I just put in 0 for the case of this. And you put in guess, and it's going to spit out another number. If it's a flat, easy number, it'll just go to whatever the correct number is. It's just going to want to pick the answer that is closest to what your guess is, which is why you want to do a high and a low guess in the sake of quadratics. So if you struggle with quadratic formula, or if you're just getting a bunch of algebra questions and you don't want to deal with it, I recommend looking into solver. I recommend learning how solver works in a lot of different ways. I am not kidding when I say I probably use that on about a third of the questions on the ACT, just because I didn't feel like handwriting it all out. Because you don't have to. No one's asking you to solve it in a specific way. You just have to get the correct answer. Okay? Little bit technically unscripted, but I figured we're allowed to use the calculator. I want to make sure you guys know the full extent of what this calculator can do for you guys. Okay? Even like I'm selling it. But if you forget your calculator, always remember the quadratic formula. I don't think I have to go super into it, especially, your b value is going to be your bx. Your a value is going to be your ax squared. Your c is just your constant c. Okay? Like calculus, how that's plus capital C, except it's algebra, so it's a lot easier. So, on to the next little segment. Oh, wow, there's text here. I don't know why I didn't say go to the text. Matching a quadratic equation with their graphs. So, you can find the vertex coordinates. You can identify the axis of symmetry. All of these are methods. You do not have to do all of those in order, especially with the ACT, because a lot of it's going to be pretty intuitive. It's going to be shifted up, or it's going to be shifted to the side of it. We'll go over problem solver. If you want to throw that in the Q&A, I'll go over it again in the end. I don't want to spend too much time on it currently. We have more time at the end, go over it again, okay? So, does anybody want to explain how you move a parabola up and down in the chat? And does anyone want to explain how you move it left to right? I especially want somebody to explain how to move it left to right. And yes, these are recorded. Just come back to this link after the stream. And yes, you could do Polysmith 2 or Polysmith. It's different for different calculators as well. I think solver is a little bit better to know generally because it can help you with more things. But yes, you can use Polysmith 2, and I believe that opens up when you hit, yes, that's going to be number 9 if you hit apps, which is, again, completely fine to use since it's not separately downloaded. Your apps button is diagonal to your green alpha button. You go onto that, and you can go down to 9. But yes, AP class study got the left and right perfect, and that was the one I was really hoping someone would touch on. If it is moved to the left or the right at all, it is going to be, a plus is going to move it to the left, so it's going to do the opposite of what you would expect on a left to right scale. And a negative is going to move it to the right, okay? At the end, your plus, sorry, I apologize. Your plus 2 or minus 2 is going to move it your right and left, or left and right, more correctly. X plus 2 or x minus 2 is going to move you up and down. Again, pretty easy. If you're needing to figure out how much you're moving up and down, you might have to get the full quadratic factored out. And then to flip it, you just make that negative, make those x's negative. Just flips it right upside down. The x to the squared, if it's positive, you're smiling. It's a positive day. If you're sad, it's a negative day. So the x squared is negative, and you're sad. Who is typing? Dylan, are you typing?
Has my mic been on this whole time? I'm so sorry.
No, don't be.
I'm so sorry.
No, why?
Oh, he's typing.
Anyways, ASMR for you guys. So yeah, again, these, if you're somebody who works a little bit better with formulas, keep these in mind. Most people does not work that way. Finding how much you've moved to the left and to the right, again, AP class study, doing amazing. Finding out how much you move to the right, left and right, just remember that negative is going to move you towards a more positive, what looks like a more positive x value on the coordinate graph. A plus is going to move you what looks more negative. Keep that in mind. That is the biggest trick with matching quadratic equations with their graphs. Next section. Exponential equations. These are a little weird. And I would say the most important thing you have to keep in mind is being able to recognize what an exponential function looks like. In this case, it's going to be f of x equals a times 1 plus r to the power of x. If it's decaying, it's going to be 1 minus r. But mostly keeping in mind that a times 1 something r, the power of x, especially that power to the x, that should be an immediate indication that something funny is happening here in terms of exponentiality. Exponential growth and exponential decay seem different. They seem like they might be different processes. They're going to be very similar concepts, and being able to recognize the difference between, exponential growth versus a parabola is going to be your best friend. And even in the case that you're like, there are two exponential growth functions here, I'm not sure which one is the graph. Take the two exponential growth functions and calculate it into your y equals on your calculator. In this case, I will do 4 times 1 plus 3 to the power of x. Punch that into your calculator. And then just hit graph, and it'll show you what your graph is going to look like. And the ACT is never going to throw anything that doesn't look vastly different from its another graph at you. It's never going to be like, oh, look at these two graphs that look remarkably similar. Figure it out. No. It's going to be like, here's two vastly different graphs, but they're both using exponential growth. Which one's the one that we're showing you right now? Or here's a bunch of different graphs. Which one's the exponential one? That's the most that you're going to see. So keep that formula in mind for what the structure looks like. But otherwise, don't stress yourself out too much. Don't stress yourself too much in terms of having to solve for any number. You're not going to have to deal with that. Okay. And then this is more of a quick reminder. If you're not familiar with your exponent rules, write these down. Write them down time and time and time and time again. We went over that at the beginning. Here's more of them in case it's beneficial for you to see more of them. Again, keeping in mind those first three, the x to the power of a times x to the power of b equals x to the power of a plus b, the division being the negative version of that, and then x to the power of a to the power of b being multiplication. There you go. You're completely good in that case. X to the power of 0 might be beneficial to remember that it's 1. I have never seen anything where that has been a huge deal, though. The rest of those, beneficial to keep in mind, not the end of the world. And again, if you're seeing the x to the power of 1 over a, the 8th root is just essentially meaning like, if you were to do x to the power of 1 over 2, it'd be the 2nd root of x. So it would be, if I'm going to show you root guys real quick, let's say 6 to the power of 1 over 2, or 4 to the power of 1 over 2, actually. Yeah, it's just going to be your square root of whatever x is. If you do 1 over, or x to the power of 1 over 3, cube root. X to the power of 1 over 4, I don't know the 4th root. Whatever a is, it's whatever root that is. Next slide. There we go. Linear equations. So I'm gonna give you guys a second. You're gonna see a few questions like this on the exam, and we're gonna give you 1 minute. And this isn't one that I'm going to have you like do a poll for. We'll do a poll for practice questions. But I want you guys to take a second, and I want you to isolate the y variable and solve for what it is in the end of the day. Not the end of the day as in after the stream. Just what is the answer? What is the value of y? So can we turn on that timer? I'm going to give you guys 1 minute to solve this. Very aggressive beeping. And, you know, if answers start like pouring in, I'm willing to stop the timer early if we want to, you know, do that. But I do want to see some answers being thrown in the chat. And I know 1 minute doesn't seem much time. We want to get used to the time pressure that can exist. So, and if it's not perfect, we're going to go over it. Don't stress. Amazing. Now, I am seeing the correct answer. Dylan, I think the answer shows up if we click. Okay. Yes, so what we know, x equals 3. And in this case, you're able to substitute x for 3. So you can simplify this down into 6 plus 5y equals 1. Break that down, you're going to want to subtract 6 from both sides. And this one makes it really easy. Divide both sides by 5, and you're going to get y equals -1. But say it's a little bit more difficult of a question. I have stellar news for you. There's a reason I taught you guys Solver, and we'll get back to how to open Solver again. But in this situation, since we only have one variable we're looking for, and the other one we can substitute that while using Solver. So, pulling open this tab, we know that it's going to end up equaling 1. So we can have E1 or E2 equal 1. And then the other one, we know what x is going to equal. So we can substitute that in the way that we did when solving it. So 2 times 3 plus, oh no, there's no y button. Y is just a variable in this case, just like 5 is. You could theoretically switch x and y, say that y equals 3, and then what's the value of x? So 5x in this situation is totally fine to put into the calculator for the case of solving. Now say you're not sure what the answer is. But you know it's one answer, it's a linear equation. So you can put in 0. And in this case, if you were to put in 0, and once again, you're going to hit solve or graph, the button right under solve, it's going to give you -1. And I went over this to show you guys the number of ways Solver can be helpful. If you know you're in a situation where like, I'm not sure what the answer is, I'm not sure how to solve this, but I can see it as an algebraic question. So I'm going to break it down into those parts. Okay? If anyone has any more questions about applications of Solver, how to reopen it, we'll go into that in the Q&A. Throw that into the Q&A tab, though. It's going to be right under the chat button. Okay? So amazing work. Linear equations can be hard. They're harder than people give it credit for, especially whenever they're like solved for like y and y's in the middle of the equation. And this might be an easier one, but that is about the difficulty what you're going to see on the ACT. So amazing. Treat both sides equally. That's the biggest thing you have to keep in mind. If you have the time, you can plug y back into the original equation. You don't have to. It's beneficial to check your work if you're not sure, especially if you have extra time at the end. Okay? So moving on from linear equations, system of equations. The biggest thing here, and we're going to give you 1 minute, but I'm going to give you a big reminder to isolate x using PEMDAS. There's a specific order you want to do it in, so keep the specific order in mind, okay? Or, if it's easier for you guys, if you can isolate x, or even if you can't isolate x, remember that Solver is your friend. If you're someone who likes to work it out by hand, go right ahead. If you want to test those Solver skills, it may or may not work for this question. I want to see how you guys do. We're going to throw a 1 minute timer up, and I'm going to give you some silence to work on this. Ooh, I'm seeing some different answers. Okay, I'm seeing most people deciding, ooh, there's a bug on my MacBook. Very interesting. So, let's break this down piece by piece, and again, I will show you guys how to input it into Solver if you're curious. So, first step, you're going to want to, why is there a little bug guy up here? Okay, welcome Gerald to the stream. Anyways, so, let's break this down and start isolating the x value. So, what's our first step here? Simplify it. We can factor out the 3 times x minus 6. And that's going to make it a lot easier to solve for your x here. It's going to be a lot less scary than trying to like divide all the weird factoring here. So, from here, you're going to want to use basic PEMDAS rules. You're going to want to subtract 3x from, okay, yep. Going right ahead there. Yeah, no, Dylan, you go ahead. You're good. You're good. So, yes, you're going to want to subtract 3x from both sides. You're going to want to subtract 2 from both sides. And that will very quickly bring you to x minus 20. If you want to do this in solver method, all the solving's still the same. Just put in both sides of the equation. 3 times x minus 6, 4x plus 2. So, same process of having to put in a guesstimate, all that jazz. But that one, if you understand to break it down into individual components, you should be completely all good with this. And everybody putting in the right answer is a very, very good process. I'm glad. We have a great example of why we want to double check and make sure we have the right signs, okay? So let's move on to the next one. System of equations. Isolate x or y by multiplying the equation by a factor that cancels the x or y. And then you want to isolate. So I'm going to let you guys run through this one. For you guys who are not solving at the moment, here's Gerald. He's enjoying my hand, I believe. The little guy, if you will. All right, we got our first answer in. Hey, getting some agreement. Four, 3, 2, 1. If you didn't solve in time, don't worry. This tends to be the ones that people tend to take a little bit longer on. Do not worry. You're going to take less time on some questions and you're going to take more on others. I'm seeing a lot of 7/3 though. So how are we going to start handling this equation, or system of equations rather? What's our first step going to be? Bonus points to Emma for putting what y equals as well. I can appreciate that. So in this case, we're going to want to put in what we know. We can see that, oh, hello. Bless me, oh my gosh, I apologize. We're going to want to break this down into individual parts. So in this case, we're going to want to create a system of factoring and then being able to, thank you, Jessica, thank you, Anuva, being able to break this down into, it's a little bit more of a basic component. So in this case, we're going to take -2 x plus y equals -2, or times x plus y equals -2 times 3. And that is going to give us a little bit, something a little bit more familiar, which is 2x minus y equals 4 for the other side. So if you simplify the above equation, Dylan, awesome, you're going to get -2x minus 2y equals -6. And then 2x minus y equals 4. So next step, you're going to be able to cancel out those two x's in this situation, making your life so much more easy. Because as you can notice, the -2x and the 2y can cancel out. So in this case, you're basically wanting to add these two equations together. So the negative 2x plus the 2x equals nothing. The negative 2x plus the negative 2y plus the negative y equals negative 3y. And negative 6 plus 4 equals negative 2. And at this point, you can easily solve for y. Maybe. Perhaps. Yes, so y equals 2 over 3. And at this point, you can plug this back into one of your original equations. And at this point, the one that stands out as the one that would be easier to solve is, in fact, x plus y equals 3. That one's just going to be easier to isolate the x from. So in this case, you're going to want to take x plus y equals 3 and substitute your y. You have your y equals 2 over 3 now. So x plus 2 over 3 equals 3. And depending on who you are, you might want to convert your 3 to a 3 into a fraction, in which case that would be 9 over 3, and then subtract your 2 over 3 from it, leaving you with x equals 7 over 3. Any confusion on that? Happy to go back over it. Put it in the Q&A for now, okay? Because we're going to move on to the next one. Everyone got their answer perfect on this. I am very impressed. So, solutions for system of equations. For this, basically, you're going to want to recognize when equations are going to have no solution, infinitely many solutions, and then one solution. Basically, the biggest thing for no solution is if it just does not make sense. 5x plus 2 cannot equal 5x as well, because that would imply 2 equals 0. This one, it's literally just the same slope shifted up or down, and that's what it's going to be if it's no solution. If it's even a slightly different slope, it's going to meet at some point. But if it's the same slope, and you're adding something to one side, and you're adding something else to the other side, there's no solution ever. Infinitely many solutions, on the other hand, is when you literally just have the same equation written in two different ways. In this case, they give us a really good example, a nice basic example too, of 2 times x plus 3 equals 2x plus 6. Take a second and you factor out your 2, you'll notice that they're just saying 2x plus 6 equals 2x plus 6. That is the same equation. Any x there is going to be able to work out and be added in. One solution is literally anything else. Anything else that you can think of, if it's not literally the same line or the same line on top of each other or the same line shifted up or down some ways, it's going to have a solution somewhere. That's in the case of a linear equation. All good? Makes sense on that front? I hope so, because we're moving on if no one throws in a question. Happy to go back if we need it, though. What's our next topic? Functions. This one should be a little quicker. So, going into functions a bit. The relation between the two sets. It's domain and range. Your domain is going to be your x values, your x-axis, or... Geez, my apologies again. I am very, very sniffly. Your y is going to be your y values. Aria, what in particular are you struggling with? So, your set of y values. If you get a table, x value is going to be your domain, different points of the x. Your y is going to be your range. Something can have an infinite range. Something can have an infinite domain. If there is one set point and one unset point, or two just continuous points, that is going to be infinite in this case. Okay, and then we can go back for a second if we need. So no solution. Oh.
I'm just trying to figure out if they mean the problem or the left topic, sorry.
If it's an issue with the systems of equation problem, would you or Anuva mind explaining in the you're not sure? Don't forget there's going to be a recording of this, so if you need it re-explained, you can come back. If you're unsure of what systems of equations are or how to tell if something has no solutions or infinite many solutions, please feel free to throw it in the Q&A. We'll happily go back over it in the end. Okay, back to functions. So that's domain x, range y. It's another fancy word for what those two things can be. So moving on from that again. So geometric and arithmetic sequences. These are kind of weird. They're hard to remember sometimes, but it's okay. You're not going to deal with them a lot except in application, and they'll make it very clear. They usually won't even call it arithmetic or geometric sequences. An arithmetic sequence, though, you have to add a fixed number, also called the common difference, you want to get into it, to the previous term. And basically what this is saying is like, hey, here's this initial number, and you're continuously adding this set number. So, you know, you're starting off with 5, and for every n, you're going to add 3. You're going to have 5, 8, 11, 14, 17, 20, etc., etc., etc. Goes on forever. Can go on in either direction, too, as long as you have a set starting number, and that's going to be your A1. N minus 1 is basically to make sure that at 0, or at the first number, A1, you're not throwing things in too early. Geometric sequence, on the other hand, is a little bit weirder because you're multiplying the number before it by a constant or a common ratio. So in this case, if this is going to be a lot harder for me to do off the top of my head, your initial number is 5, and your constant number is going to be 3. So in this case, you're going to go 5, multiply that by 3, you're going to get 15, multiply that by 3, 45. Basically, if you're seeing a huge exponential increase, 5 to 15 to 45, that's going to be geometric. And that one's a little bit harder to understand formulaically. But if you're seeing an exponential increase, it's a geometric. And understand that conceptually, you know, you're multiplying it by the number of times it has come up, which is why you have that exponent there. You know, the first time you'd be multiplying, it would be by 3, but after that, it'd be by 9. After that, 27, 81, and which is why the exponents the exponents come into play there. Arithmetic, you're just adding. You're just adding. Add. A lot easier. Big, scary words for pretty simple concepts. So, next part. We're going to take a second, and we're going to do a practice break. We got through most of the hard things on the ACT. We're going to have a little bit of statistics we're going to come to after this practice break. You'll be able to rest your brain after you solve these while the timer is going on, while people are throwing in their answers. And with this, take a moment, relax. If you need to run to the restroom, that's cool. This is your time to do it. If you want to practice, this is also the time to do it. We got you covered here. So, Dylan, do you want to come help us out with practice here?
Heck yeah, let me come down.
Thank you.
There we go. Howdy. All right, so let's move on to the first question here. All right, so the question is asking, what real value of x satisfies the equation log base 2 of x equals -3? So 1 minute here. Oh, yeah. There should be a poll open for this problem. So if you want to, feel free to drop your answers in the poll.
The poll should be opened now, for sure.
Cool. Thanks, Elias. All right, so that's the answer to that question, or that's the end of that question. Let's take a look at the answer. All right, so the answer here is 1/8. Right, let me see if there's there's no answer explanation written, but we'll go over it anyway. So remember, a logarithm is the inverse of an exponent. So for example, if we ask what this question is asking is 2 raised to what number gives us -3? Right, wait. Let me make sure. No, sorry. This is asking us -3 raised to what number equals 2? Sorry, I mixed it up. Wait. Yeah, right? Elias, feel free to jump in. I always forget the order of these things. I just know how to solve them.
So in this situation, you're basically wanting to figure out 2 to the power of -3 equals what, I believe.
Well, that's how you would solve the problem.
Yes.
Yeah, so basically, remember, if logs are the inverse of exponents, to isolate x, we need to raise both sides of this equation to 2 by the power of 2. So we get 2 to the log base 2 of x, which cancels out to give us x, equals 2 to the -3, which is b, which is 1 over 8, right? Because 2 to the -3 is equal to 1 over 2 to the 3, which is 1 over 8. Right, so that's how you would solve this problem. All right, so this next question. The expression 3x minus 4y squared times the quantity 3x plus 4y squared is equivalent to, and you have 4 options here. So 1 minute.
Poll is open now, you guys.
All right, so that is time. Let me take a look at the poll here. Practice 1, took our algebra here. There we go. All right, looks like we have 6 votes all for answer choice D. Let's see if that's the right answer. And it is, right? Good job, y'all. So it looks like you guys had a pretty good handle on this. A few options here. One would be back solving. That always works. Another would be multiplying this out. So foiling it. So you get 3x times 3x, which is 9x squared, plus 3x times 4y squared, minus 4y squared times 3x. So those all cancel out. And then we get negative 4y squared times 4y squared, which gives us negative 16y to the 4th. And it looks like that is what everyone seemed to do. So nice job with that, y'all. All right, looks like practice 3. An industrial cleaner is manufactured using only the 3 secret ingredients A, B, C, which are mixed in the ratio 2 to 3 to 5, respectively, by weight. How many pounds of secret ingredient B are in a 42-pound net weight bucket of this cleaner? So by net weight, they mean if the total weight of this container is 42 pounds, and we have this ratio 2 to 3 to 5 of ABC, how much of that is B? Right, so poll should be opening soon, and I'll set the timer for 1 minute.
I'm always extremely amused every time I see like one answer go in absolutely immediately. And I always have to wonder, are they like looking ahead in the slides, or are they just like always getting it that quickly? Like, I'm very impressed if it's that fast, because that usually takes a lot of practice to get to that point.
They got like an ACT spidey sense where there's like, there's no math anymore. It's just they know. It's in the air.
They can smell it.
Exactly. All right, around 5 more seconds. All right, so it looks like we have 6 votes, all for A. So let's see if A is the correct answer. It is, awesome. Yeah, so the way you would solve this problem would be basically, I would honestly just try out the answer choices. That's how I would do it, at least. Basically, you want to think of how do you split up 42 pounds into 2 parts, 3 parts, and 5 parts, such that those all add up to that full 42. So you need to find a number such that 2 times that number plus 3 times that number plus 5 times that number equals 42. Right? Am I right here? I saw Elias, you came down. I think you're still muted, by the way. Wait, Elias, I think you're still muted. I see you talking.
Wow, I was rambling while muted. Anyways, I'm seeing whole numbers. That makes this a lot easier. Thank you, guys. I know. So, in this case, each of these parts are going to be basically factors or larger numbers of a same root number. So what I would do in this case is add 5, 3, and 2, and then divide 42 by that added set of numbers, because no matter what, it's going to equal up that ratio. So if you divide 42 by 10, you're going to get 4.2, and then you see that secret ingredient B is 3 out of the 10 parts of this. So you can multiply your 4.2 times 3, and in that case, you get very quickly to 12.6. Anyways, that's my little ramble.
Awesome. Thanks, Elias. Elias is totally right. If we just basically want to find our unit, and then once we can find our unit, we can very easily multiply by whatever our ratio is to find our exact numbers. And we'll see a little bit of a version of this when we talk about statistics, actually. This is secretly a statistics problem. They're all statistics problems. Okay. All right, speaking of, let's talk about statistics and probability. I'm so excited. Elias was so amazing with all the algebra stuff. I'm scared to try to top it, but I have statistics and probability on my side to help. So I'm so excited. I love statistics and probability. This is going to be fun. All right. So basic probability, right? What is probability just to begin with? So the way we define probability is basically the probability of something happening is the number of ways it can happen divided by the number of ways anything can happen. That's called the sample space, all of the stuff that we can have happen. So for example, if we're flipping a coin and we know we can either get heads or tails, that means our sample space is heads and tails. The probability of us getting a heads, there's only one way to get heads. So the probability of getting heads is one way to get heads over 2 total ways for that to happen. And we notate that with n of x and n of a to just mean like the number of ways this outcome can happen. Likewise, the probability of x not occurring is 1 minus the probability of x occurring, right? And that kind of makes sense because if x either occurs or doesn't occur, that should have probability 1, right? It's either going to happen or not. And so that's kind of a definition of probability that might help if you're dealing with a probability that's kind of difficult. It might a lot of the times be easier to ask, what's the probability of this not happening, and then subtracting that from 1. That's sometimes a lot easier. And again, if you guys have any questions about this, feel free to ask. Probability is hard, and it's not obvious. So as we go through this, I'm going to try to give as many examples as possible to try to give it some sort of like tangibility. But it's hard. So as we move through, if you have questions, feel free to ask. So here's an example, right? Suppose you have an urn with colored discs. If there are 15 red discs, 30 blue discs, and 12 yellow discs, what is the probability of picking a blue disc if you pick only one disc? And just for context, an urn is like a bowl, and colored discs are like, little pieces of plastic, basically, imagine. So I'll give you guys a few seconds to think about this. This isn't like a formal problem, but just think about this for a few seconds. I'll give you guys, 30 seconds just to kind of think about how you would go about solving this problem, and then we'll talk about the answer. So let me get a timer up. Just, again, this isn't like if you can't get this in 30 seconds, don't freak out. I'm just giving you guys a few seconds to just to think through it. Right, and remember, if we want the probability of picking a blue disc, well, how many ways are there to pick a blue disc? And how many ways are there to pick a disc total? And that's, by definition, what our probability is. So this actually should be you might be able to solve this in less than 30 seconds. And if you get the answer, feel free to share in the chat. (30/57), I'm seeing. Okay, that's 30 seconds. So yeah, so let's go over this. I saw M&A said 30/57. And that's correct, right? There are 30 blue discs and a total of 57 discs. So the probability of picking a blue disc is 30/57. There are a number of ways to represent this, right? With 30/57, 0.526, 52.6, percent. There's a number of ways, and these all mean the same thing. And this notation here, this P blue right there, that's just saying the probability of picking a blue disc. That P means probability. Okay, so now that we know how to find the probability of something happening, let's talk about how to find the probability of two events possibly happening. So for mutually exclusive events, x and y, the probability of x or y occurring is x plus y. There's the probability of x plus the probability of y. Where mutually exclusive basically means it's either one or the other. We can't have both happening. So for example, suppose we are flipping a coin and rolling a die, right? The probability of flipping heads or, I just realized this is not a good example. Because there's a possibility of getting heads and flipping. Okay, you can ignore this example. That is wrong. That's embarrassing. Basically, think about if you have two events that can never happen at the same time. For example, rolling a die and rolling a 4 or a 5. Right? You can't roll both a 4 and a 5. Or Juliana is a great one. It can't be Wednesday and Friday at the same time. That means they're disjoint or mutually exclusive. To find the probability of two mutually exclusive events, you just add the probabilities. So if I roll a die and I say, what's the probability of me getting a 5 or a 6? Well, what's the probability of getting a 5 is 1/6. Probability of getting a 6 is 1/6. So the probability of getting one total, a 5 or a 6, is 2/6, right? Because it's 2 of the possible 6 answers. Let me look real quick. Yeah, so this example here, down here, is not mutually exclusive, right? Because you could roll a die and flip a head, and you could get head and 4. There's a possibility of that happening. And there's some ways to handle that, but you won't be required to do that on the SAT, or ACT, excuse me. So feel free to ignore this bottom problem, or treat it as correct and just assume you can't get a head and roll 4, just under that assumption. But yeah, this is a bad example for what we're talking about. And on the ACT, they will always be mutually exclusive, so you don't have to worry about like logicking it out. We can think about this with Venn diagrams a little bit. I love this personally. What we mean when we say mutually exclusive events is that there's no overlap, right? If these are all the ways X can happen, and these are all the way Y can happen, there's no X and Y. Whereas here, there's A, there's B, there's A and B. That little cap is a symbol for A and B. Yep, and Juliana's totally correct, right? It's called the inclusion-exclusion principle. Very fun. If you are interested in statistics and probability, you'll need to learn that at some point. But yeah, so this is an overlapping, so these events are not mutually exclusive. There is a probability, there's a situation here where you can get X and B, or A and B. So that's, when you're doing probability, if you're confused, drawing out a Venn diagram might be pretty helpful. All right, so we've talked about the probability of X or Y. Now let's talk about the probability of X and Y. So for independent events, independent meaning the probabilities don't impact each other, the probability of X and Y occurring is probability of X times the probability of Y. And we'll talk about dependency in a little bit, but let's look at this example. Suppose we flip a coin and roll a die, our classic example. What is the probability of getting tails and rolling a 6, meaning both things have to happen, not one or the other? Well, probability of tails is 1/2, right? The other heads or tails. Probability of getting a 6 is 1/6. There are 6 possible things for a die. So we multiply these together and get 1/12. And this should make some logical sense, right? You get a 50-50 chance of getting a tails. You get a 1/6 chance of getting a 6. The chance of getting both should be lower, right? Because you're doing more unlikely things, right? Or unlikely meaning not exactly 100% likely, right? If I'm doing two things that may not happen, the probabilities will be lower. Likewise, if it's or, the probability is really higher because the probability of one of two things happening is higher than the probability of one thing happening in general. Excuse me. For dependent events. So for example, if what's a good example of dependent events? If I roll 2 die, right? Or no, those are independent. I need an example of dependent events. 1 second. Okay, perfect. So like if you are picking marbles out of a bag and you put you don't put the marbles back. So let's say I have 10 randomly colored marbles in a jar, and I say I pick one, and then I pick another without replacement. The probabilities are going to be different for that second pull than the first. Therefore, the events are dependent, not independent. For dependent events, the probability of x and y is the probability of x times the probability of y given x has occurred. That's not really tested too often. It'll be maybe one question, so I'm not going to go super into it. But if you'd like to go into it, I'm happy to talk about dependency and conditional probability. But yeah, you probably won't see it on many questions, if any. There are no practice questions here that involve it. I've never seen it on ACT, but I saw some blogs that discussed it, so I figured I might as well put it in here. But yeah, so for example, if I say I have, 5 red and 5 blue marbles in a jar, what's the probability of getting 1 red marble and 1 blue marble without replacement? The probability, let's say I pull a red marble on that first pull. What's the probability of getting blue? It's not 5 out of 10, it's now 5 out of 9. So the probabilities are dependent on one another, right? We need to make sure the first event has happened and find what the probability of that is, because it's dependent on whether or not the first thing happened. That is conditional probability. All right, so combining the two, right? Suppose we flip a coin and roll a die. What is the probability of getting tails and rolling either a 6 or a 4? Right, where the 6 or 4 is kind of the first thing that has to happen. Well, we have an and, so we're going to multiply these two things. We know they're independent because A on the ACT, they always will be. And B, they kind of just logically, one's not going to impact the other. So the probability of tails and 6 or 4 is the probability of tails times the probability of rolling a 6 or a 4, right? Because we know what that means with an and. Then the probability of tails times the probability of 6 plus the probability of 4, because an or means we add. And so that is 1/2 times 1/6 plus 1/6, which is itself equal to 1/6. So that's how you would kind of break down a problem like this, where you're involving a couple different layers of probability. And again, if you guys have any questions about this, I know I'm moving through this quite quickly, feel free to drop a question in the chat. All right, expected values. Right, this is kind of a rare value, but a rare question, but it's shown up before. So the expected value of a random variable, which basically just means like the outcome of an event, is the weighted average of its possible values. So for example, let's say we're playing a game where you have a 40% chance of winning $100 and a 60% chance of losing $100. Let X represent the amount of money you win. What is the expected value of X? So basically we have a 40% chance of gaining 100, 60% chance of losing 100. On average, if we play this over and over and over and over and over, on average, we'll lose $20, right? If we play this to infinity, at the average, we'll lose $20. And we know this because we can multiply 0.4 by 100 and 0.6 by negative 100 and add them. That's called a weighted average. And that's expected value. It's, again, kind of lightly tested, so if you have any questions on it, I'm happy to do more examples, but it's probably not going to show up too heavily. This is the formula. You don't need to have this memorized, but basically it's just the weights, like the probability times the value, all summed up. It's just a weighted average. All right, so here's a sample probability question, right? This one is a little bit more complex, but is just about the same as understanding just how probability works in general. So a bag contains 12 red marbles, 5 yellow marbles, and 15 green marbles. How many additional red marbles must be added to the 32 already in the bag so that the probability of randomly drawing a red marble is 3/5? All right, so this is a real practice problem. I'm going to give you guys 1 minute to solve this. You got 1 minute, 1 second. All right, 1 minute has started, and I'll kind of just hold it up here because I don't have a timer. All right, so that is time. This question is kind of interesting in that it requires you to understand how probability works, but you aren't just calculating a probability, right? It's more working backwards and figuring out a probability. Right, so here's how we get to the answer of G. So G was the correct answer here. So let's say we added X red marbles to the bag, right? That's what we've been asked. So the probability of getting a red is going to be 12 plus X over 32 plus X, right? We know this because the original probability was 12 over 32. We've now added X ways to get a red and X total events as well. We set that equal to 3/5 because we're told the probability is going to be 3/5 at the end. And then we solve algebraically. So we cross multiply, and then we simplify and solve for X to get X equals 18. So really, this isn't even really a probability question. It's an algebra question that requires you to just understand what the definition of probability means. The real trick here was understanding that you need to add X to both the numerator and denominator of this probability, because we've added both ways that we can get a red and more marbles in general. If the question had asked, how many yellow marbles do we need to add to get to a certain probability of red, then we'd only add to the denominator, because we're looking for how many ways can we get red over how many marbles are there. Does anyone have any questions on this, or do we all feel pretty okay with how we would solve this question? If you have any questions, feel free to drop them in the chat. Okay, so statistics, right? Statistics on the ACT is pretty light. Pretty simple. You've probably learned a lot of this in your math classes already, but it basically involves a few measures of how we look at data, right? So the basic ways we look at data, first and foremost, are our measures of central tendency, right? And those are our mean, our median, and our mode, right? So the definition of a mean is going to be the sum of all the values divided by the number of values. So essentially, let's say we have, a set of numbers like 2, 4, 6, and 8. The mean of those numbers is going to be 2 plus 4 plus 6 plus 8 divided by 4, because we have 4 numbers. Median is the middle value when numbers are ordered. So basically, literally, if you ordered them in a line, what's in the middle? And it doesn't necessarily equal the mean. And mode is the most common value. So what number shows up the most? So if I have a data set like 1, 1, 1, 1, 1, 2, 3, 4, 1 is the mode. They can be equal. They don't necessarily have to be equal. But the reason these are so important is because they're measures of kind of the middle of data, right? The mean is the arithmetic center of data. It basically means if I took all of the data I had and spread it evenly across all of the records, what would that value be, right? It's that like middle value of equality, right? Median is the literal middle. It's the, if I have all this data, what is the central point? And the mode is the frequency center, right? What do I have the most of? So those are our definitions of mean, median, and mode, and kind of how we think about them. The ACT might ask you to calculate them, might ask you to understand and interpret them, might ask you to compare them. There's a ton of different ways they could ask you about this. And really what's important is understanding them conceptually and understanding them computationally, right? Just because you've memorized the formula doesn't mean you really understand, well, what is a mean? What is a median? What is a mode? And that takes some practice, which we'll do. So here's an example statistics problem that involves a mean. Tom has taken 5 of the 8 equally weighted tests in his US history class this semester, and he has an average score of exactly 78 points. How many points does he need to earn on the 6th test to bring his average score up to exactly 80? All right, so this is an average question, but isn't just find the average. So you have 1 minute. And feel free to drop your answers in the chat when you're ready. I'm doing my best, Elias. I'm doing my best. So remember, what is an average, and how can we use this to solve some algebra questions might be asking? "15 seconds. All right, so that is time. So this question really is all about understanding how a mean works and how we can turn that into an algebra question. This is a very common type of question on the ACT. All right, so Emanade says A. Feel free to drop your answers in the chat. But here's how we do this. So the average across 6 tests is going to be the number of points on those 6 tests divided by 6, right? 6 tests. We know he averaged 78 points across 5, meaning he scored a total of 390 points, right? Because if we think about how we would find the average of 5 tests, that's the total number of points divided by 5, which we know equals 78. So we know that the number of points has to be 78 times 5. We don't know how that's split up. He could have gotten a 380 on his first test and then a 2 on the others. But we know he's gotten a total of 390 points. Therefore, we need to solve 390 plus x, whatever x is on our next test, divided by 6, and we want an average of 80, so we set that equal to 80. Solve algebraically. So multiply both sides by 6, subtract 390, and we find that indeed x equals 90, which is answer choice A. So good job, Emanade. Right, so here's an example where just because you know like the mean formula by heart doesn't mean you would actually be able to get this question easily, because you need to understand how does the mean work, right? What is that formula actually saying? And what it's saying is if I have these many points and I spread it evenly across a certain number of tests, how many points would I allocate to each test? That's a mean. That's what an average actually means. All right, so the last thing we're going to talk about are measures of spread. So range and standard deviation. So range is just the span of a data set. So if I have a certain data set, it is the difference between the maximum of that set and the minimum of that set. Just literally the range, right? What are the barriers on that data? Similarly, variance and standard deviation measure the average squared distance from the mean. Where the standard deviation is just the square root of variance. So what this basically means is, and this is confusing, basically on average, how far, if I pick a data point at random, on average, how far is that going to be from the mean, right, the center of my data set? If that number is really high, if on average my data points are all over away from the mean, my data is really spread out. But if on average my points are really close to the mean, I don't have much variance in my data. Right, my spread is pretty small. So that's kind of what variance and standard deviation means. Most questions asking you to do these things is more going to be about comparing. So if I give 2 data sets and I say which one has the larger range, larger standard deviation, that's especially true for standard deviation because it's a pain to do by hand. In fact, it's like borderline torture to do it by hand. I've done it like twice. I hate it. I'm sure there's a way to do it in your calculator, but they'll never really ask you to calculate it because it's such a pain, and requires just a ton of like subtracting and squaring and square rooting and adding, and it's a mess. So yeah, so really understand this concept conceptually, less than try to be like, well, how do I calculate it? Right? If you understand that standard deviation just means like how far am I from the center, and range means what is like the spread, you're good. So for example, here's a comparative question. Which of the following statements about the plots of GPA at 2 schools is true? A, the standard deviation of GPAs at A is smaller. The standard deviations at B is smaller. The standard deviations are the same. Or I don't know. I can't tell based off the information given. And that just doesn't mean I don't know, but it means I can't know.
I think all the ACTs should have an answer choice that's I don't know, and you get full credit for it.
I would love that. That'd be awesome. But you can only answer that on like 3 total questions. It's like a freebie.
Oh, that'd be amazing.
ACT executives, if you're here, Elias and I would love to join your board. 45 seconds. All right, so remember, think about what does standard deviation mean? And how can we apply that to this problem? Oops. And after you answer this question, there should be a link to a survey about your Cram experience tonight. So if you could fill that out, we would greatly appreciate it. 5 more seconds. All right, so that's time. So let's talk about this question, right? Again, there's no numbers to be had here. You don't need to do any math here. We're seeing a bunch of answers of A. And A is correct. We can see that plot A has a smaller spread than plot B, and that implies that A has a smaller standard deviation. On average, points are closer to the mean in A than B. And we can kind of see this visually. The mean here is like roughly right around there, right, the middle. Here, most of our data points are between 2 and 4 away from the mean. Here, on average, it might be like, on average, on average, our data points might be like 1 or 2 away from the mean. Here, our data points are like 2 or 3 away from the mean. So that's kind of how we can compare them, right? This is a flatter and a more varying distribution. Okay, integrating essential skills, right? We've learned all this material. How do we bring it together? Right, so this section is a catch-all, right? It basically says that students can use multiple types of math to solve a complex problem. So this is anything from word problems to predicting outcomes, determining best fit, interpreting graphs, basically things that will require you not just to use one sole topic, but understand how things work together in math. Right, so just because we learned statistics separately from algebra doesn't mean you won't need both in a single problem. As we've seen, we needed algebra to solve some of those statistics problems earlier. Likewise, just because you know how to complete the square on a quadratic doesn't mean you won't be asked that in a geometry question about circles. You might. So really understanding how math works together and is integrated and isn't just like a list of discrete topics is really what this is about. You can't really practice this section outside of just really being mindful of it and understanding that there aren't types of problems on the ACT, right? There's skills that are best adept for problems, but just because someone's like, oh, this is a factoring problem, doesn't mean you couldn't complete the square. It just means that factoring might be the clearest solution to that. So that's kind of what this is saying, right? Is that anything is fair game. If we've talked about it once, we can include it anywhere because you should understand it. That might be scary, but it actually is to your advantage because it means that those problems are going to be able to be solved in 8 different ways, which means you're more than likely to know one of them. All right, so let's get into some practice, right? We'll be practicing all throughout tonight. I might shift some of the timings to 30 seconds if it's an easier question, just for the sake of time, so we have some time for Q&A. But yeah, these are ACT practice questions, so give yourself around a minute per question otherwise. Okay, the sum of the first 4 terms of the arithmetic sequence in which the sixth, what is the sum of the first 4 terms of the arithmetic sequence in which the 6th term is 8 and the 10th term is 13? Remember, an arithmetic sequence, a constant difference. So 1 minute on the clock. Ooh, I don't have to use my phone anymore. This is awesome. And I think there should be a poll. And yeah, it's arithmetic. That's how for the sequence. Yeah, so drop your answer in the poll when you're ready. It looks like the poll is visible. All right, so let's take a look at the answer. I mean, I just want to note for Elias's comment that it's arithmetic. It is arithmetic. It's arithmetic when it's an adjective, arithmetic when it's a noun. So for example, I learned arithmetic, but this is an arithmetic sequence. I like this word a lot. It's a good word. So let's take a look at the poll. Problem 1, all right. So it looks like we're split between either A or C. We have 2 votes for A, 1 vote for C. And the answer is B, actually. Right, so is there a, okay, there isn't. So let's think about what an arithmetic sequence means, right? An arithmetic sequence means we move with the same constant difference each time. So if our 6th term is 8 and our 10th term is 13, we've taken a certain number of steps to get there. So, give me 1 second. So if we have the 6th term as 8, we have to jump to 7, then 8, then 9, and then finally we get to 10, which is 13. And we have to jump the same amount each time. So for example, I can't jump from 8 straight to 13. I have to jump from 8 to maybe, let's say, 10 to 12. Well, that doesn't work. And we have to figure out what that common difference is. The way we can do this is we can find, well, how many did we jump across those 5 steps? We jumped in 4 steps, right? We jumped from 8 to 13. That is a difference of 5, right? So we jumped 5 spaces in 4 total steps, right? So therefore, our common difference is 5 over 4, right? So now we can just work backwards from 8 to get our first 4. So we get 8, subtract 5 over 4, subtract 5 over 4, subtract 5 over 4, until we get to our first term. And from there, we can add them together. It's a bit of a tricky question, but really all it hinges to is understanding how we find that common difference and how we then can work backwards from the 6th term to get the 5th, 4th, 3rd, 2nd, and 1st term, and then we can add them over. And this is where a calculator might be really helpful to just add those together. All right, problem 2. I think we already did this question, so I'm actually going to skip it. We did this question during the practice earlier. So the answer was the same. Yep. Okay. So this is a good question. Problem 3. For what value of A would the following system equation have an infinite number of solutions? Right. So remember, infinite number of solutions means they're the exact same line. I'm going to give you 30 seconds for this one because there's a little trick here that I hope you notice. And the poll should be opening very soon for practice problem 3. Let's see, problem 3. There we go. Yes, it's open. All right, so that's 30 seconds. So the trick here is to notice that we've actually multiplied this equation here by a certain number. We've multiplied 2x to 6x, negative y to negative 3y, and 8 to something. So we can see clearly here we've multiplied by 3, right? So here, this has to be equal to 24, or excuse me, yeah, 24. So if 4a is equal to 24, the answer must be C6. So it's actually not as hard of a problem as you might think. The real key here is realizing how do we make these the exact same equation? It looks like everyone, 4 of us out of the 5 who answered seem to get that. All right, question 4. Sales for a business were $3 million more than the second year than the first, and sales for the third year were double the sales for the first year. If sales for the third year were $38 million, what were sales for the first year? This is tricky, I think, solely in the fact that the wording is really weird. But so 1 minute on the clock. This actually isn't too hard of a problem when it comes to the math. So I'll give this one a minute. This one might be helpful also maybe to work backwards. Or just be very careful about what was happening in each step. Yep, back solving is also totally an option here. Nice point, Juliana. All right, 5 more seconds. All right, and that is time. So let's take a look at what everyone said. This is problem 4. And everyone seems to say A. Perfect, right? So the answer is C, actually, right? So let's think about how we would solve this, right? So if sales in the third year were 38 million and they doubled between the second and third, we know that the second year sales must have been 19 million. Yeah, actually the answer here is A. Because if sales for the third year were 38 million, that means the second year had to be 19 million because they doubled. And therefore, in the first year, it had to be 3 million less, which is 16. So the answer was A, $16 million. Right, I think that's right. Yeah. And actually, we knew the answer couldn't have been C or D because double either of those answers is already above 38 million. Yep, 16 million is correct. All right, question 5. What is the greatest common factor of 42, 126, and 210? I'm going to give you guys 30 seconds to solve this, because this shouldn't take too long. Especially with a calculator, actually, this is a really quick question with a calculator. So 15 more seconds. All right, so let's take a look at what y'all said and what the answer here is. Oh, it looks like the poll never went up. That's all good. Problem 5. There you go. Feel free to drop your answers in the, that's problem 8. Problem 5's right here. Feel free to drop your answers in the poll there really quick. We'll give you guys a few seconds. Looks like a couple D. Let's see, is D the right answer here? It is, right? So the greatest common factor basically means the greatest number that can divide 42, 126, and 210. The way I would do this is just by taking each of the answer choices and literally doing 42 divided by that number, 126 divided by that number, 210 divided by that number. And whichever answer choice gave me 3 integers first, which would be 42, would be correct, right? We're looking for the greatest common factor, not just a common factor. Okay, that was, yeah. So that's how you would solve this question with a greatest common factor. Just literally what is the greatest number that divides all of these numbers? Ooh, a probability question. Nice. So George has 4 sets of socks and 4 sets of shoes. Each pair has a different color: white, brown, black, and blue. If George selects a pair of socks and a pair of shoes, what is the theoretical probability that George will choose a pair of white pair of shoes, and a pair of socks that are not white? This is a fun one. I'll give you guys a full minute for this one. Let's make sure the poll is open. 6. I'm actually going to give this one a quick stab because this might be take a second. That is a time-consuming question. So let's see what people said for problem number 6. Unless I didn't open the poll, in which case that's embarrassing. Okay, good. 2 people said D, right? So perfect. I think that's correct. That's what I got at least. Yes. Okay, so the answer is D, right? So we kind of want to break this one down moving in. So the probability of choosing white and not choosing white for socks is going to be the probability of choosing a white pair of shoes, which is 1/4, and the probability that they're not white is going to be 3/4. We multiply that together and we get 3/16, which is 0.1875. Boom, mic drop, probability. And that's going to be the last question we have tonight.
Amazing work with probability and statistics, Dylan. 10 out of 10, a 100% chance of being amazing.
Nice one. You did great too. Algebra is fun. You killed it.
Yeah. So amazing. If I don't fall out of my chair. Amazing work, everybody. Had a great time tonight helping you guys. Our guest of honor is back. Steven, do you have any words?
Thank y'all for tuning in. Math section is always definitely a little bit of it's a lot. It's a lot, and it's very different from English, especially with ACT. So I appreciate y'all hanging out, and we just feel like we flew through content tonight. Please make sure that we're filling out that survey at the bottom. It's really important for us. It gives us a lot of good information and feedback, and we really, really take that to heart. We really look at that survey feedback. I know sometimes you fill out a survey and it just gets sent out in the void, and we're like, I don't know if that's doing anything. We promise we read every single survey result. So please give us your honest feedback. We do really appreciate it. Thank you all so much. Tomorrow we have writing and language for ACT. So again, we're kind of just like it's like getting whiplash over here, going from humanities to STEM to humanities. But we will see you all then. Thank you all so much, Elias and Dylan. Thank you guys. And we'll catch y'all next time.
Thank y'all. Thank y'all for coming. I'll see you guys tomorrow. Adios.